we are back. We are working on the Titan 1M and we got through the first page, so let's go on to the next one. So in this page we have a couple of holes that we need to drill. So what we're going to do is we are going to make sure that part 1 is active. Don't be accidentally selecting a different component or assembly and sketching in that and then modifying a part. So what that basically means is if I create a sketch right now and I put it on this plane, it'll pop up a sketch right here. And the problem with that is that sketch is actually not going to be associated with the part. So if you were to use this part in another assembly elsewhere, the references would be broken pretty badly. That doesn't mean you won't see your feature, but your references will definitely be broken. So I'm going to get rid of that sketch right there. Make sure that I have my part highlighted because I'm still working on it, and I'm going to create a sketch. I picked a surface which was the top of that part, and now what I'm going to do is create a projection. A projection is used to link the a 3D feature or any kind of feature outside of the sketch to the sketch. So if you have a look, all of these holes are positioned in reference to 0, 0 in the top left corner. So I'm going to create a projection out of 0, 0. So come right here, projection, select that point right here and click OK. Now projections are always colored pink and you can't really do anything to constrain them. They're linked to the solid body on the bottom or any other feature on a different plane or intersecting plane as the sketch. So don't worry if they're pink. The next thing I'm going to do is find out how many holes I have. 1, 2, 3, 4, 5, 6, 7. So to make the holes, I'm going to place 7 points. Now these are very unconstrained points, so we're going to start constraining them. Let's start with this one right here. This one is 1.5. I'm sorry, it's 0.15, and it's also 0.15 in the y direction. So I'm just going to take that. Now if I wanted, I could just type 0.15, but since it's a same dimension as this one, I can also link it by clicking that other dimension D7. And now whenever I change this, the other dimension changes as well. Now this is the first time this is where an engineering CAD really gets powerful. If you link your parameters, these are called parameters, in a logical manner, you can have CAD models that can be repurposed for many uses, or you can account for uncertainties about sizes and dimensions. So we're going to use parameters a little bit, and parameters are really important when you're doing engineering CAD, and they will come in handy when you're using center resources. I'm just going to highlight them, but their use is pretty irrelevant, at least in the first few places I'm going to use them. It's mostly a matter of convenience rather than future application in this case. So let's go on to this point. I know this point is 1.5 on the x-axis and about 1.75 on the y. So I'm going to quickly go about this. .15. So I'm just going to go here, put that. .3. Now you can also apply equations with your constraints. So I can type 0.3 if I want to, but I can also take this dimension, multiply it by 2, and that gives me 0.3. Now I just did that for demonstration, but you can have logical dimensions that one dimension might be triple the other dimension, and you can use that to make your CAD model adaptable. Because if now I change this to 0.2, all three of these points change because of how they are linked. Changing it back, now I'm gonna get this one and this one here. See what that value is, 2.85. And this one and this one. I'm gonna link it to this one right here. Now this one is 3.85. Take this point here and here. Take this point here and here. Make that equivalent to this right there. Now let's do this one. So this one will be the same as this, and this one will be the same as this. Enter. That only leaves us 1 point. That is 2 inches and 1.216. 1.216. And another constraint, 2 inches. And you should make it a point to clean up your dimensions, because if someone's reviewing your sketches, it makes it a whole lot easier. Now I'm gonna finish sketch. Now technically it's completely possible to just draw circles and make holes through extrusion like we made the rectangle, but in our case we're just going to use the hole feature. So I'm gonna go back here. It tells me it's a 1032 UNF2B tap. So I'm going to select the holes. And here I'm just going to go for a tapped, and I'm going to go for partial tapped with a pointy tip, not a flat tip. Now this is just to account for the fact that this is actually going to be manufactured. Now I can set the size to number 10. Now 32 seems like a non-standard UNF. Yep. In our case, we're just going to stick to the 1024. Again, this is something you can change on the fly if the facts change. Now if we come back here, it says 0.38 minimum. So we need to make sure we go at least that deep. So this value right here is 0.38. So that's already taken care of. Now when it comes to the tapping, if you have a 0.38 deep hole and it's not going all the way through, you can't tap all the way to the bottom. The tap will physically break if you try to tap all the way to the bottom. So you're going to tap a little bit of the way there. You don't have to go all the way to the bottom. So I'm just going to go for 0.2. Now you guys will have a different value here. It's probably going to be 118. Now that's the standard value for the taper angle of a drill that is used to drill this. In our center, it just happens to be that our drills are a little more specialized and they have a 140-degree taper angle or tip angle. Now one thing that is good to show off but is not really ever useful in practical engineering CAD is modeling threads. So if I want, I can just have a representation of a thread, or I can model it. Just for illustration purposes, we're going to model it and see what that partial thread looks like. So the threads have been created, and I'm going to use a tool under inspection called section analysis. I'm going to take this section and I'm going to go a bit back. Now if you guys have a look, the threads are only half of the way there. This is what I mean by a partial thread. Now we don't really need this section analysis, so I'm going to hit cancel. And I'm going to come to the timeline and modify this to not be model, because modeling the threads only makes things difficult. And we're going to click OK. And with that, we have completed the holes part. We're just going to hit Command Save, click OK. And we have another sketch where we drew the points, and then we have our whole feature. That's it for this session. I'll see you guys on the next one.